functions. I know that by now you guys have seen this a couple times, so here's a little refresh. The square root graph, the parent graph, looks like this, which is just the standard f of x equals square root x. So this is something that should be in your mind as we're talking about these, is like the first point is typically 0, 0 on the parent function, it is 0, 0. And then it kind of curves up and over from there. So that's kind of like if you were plugging in points. If we plugged in 0, square root of 0, 0. If we plugged in 1, square root of 1 is 1, so 1, 1 would be a point. Let's say we plugged in 4 for x, square root of 4 is 2, so 2 would be our output. So the point 4, 2 is on this graph, and so on. The domain, so that possible x values that you can plug in are anything that are greater than or equal to 0. So that just means we can't plug in negative square root values and get real answers. The range, since the lowest x value we can plug in is 0, we would plug that in and figure out what the square root of that is. So in this case, it's 0. The intercepts, they cross the x and y intercept at 0. It's not defined, which means there are no real solutions if x is less than 0. Okay? And the end behavior as x increases, y increases. So that's the idea of the graphs. We will get into some graphing in a little bit. But let's look at the example 1 here. It's just talking about the domain and range. So it's not asking us to graph just yet. So our goal is to figure out what possible x values can I plug in here. So what I want to do is I want to focus on this stuff in here and say, okay, well, I know that whatever underneath the radical, it cannot be negative. So I'm going to say x plus 4 has to be greater than or equal to 0 because I know it's not going to be negative. So if I were to solve that inequality, x is greater than or equal to negative 4. So the smallest x value I can plug in to my domain is negative 4. So your domain here, domain, is everything that is greater than 4. So x is greater than or equal to negative 4, sorry. Okay, formal way to write it is x is such that x is greater than or equal to negative 4. I'm not going to require that, I'm just showing you guys. Also demonstrating again that I can't draw those little brackets. But so if negative 4 is the smallest x value I can plug in, I'm going to put that in there to find the smallest output, the range value, y value, whatever you want to call it. I'm going to plug in that negative 4, and that's going to get me 0. The square root of 0 is 0. So your range, now the smallest option you can have for your range is 0. So everything x, f of x, is going to end up being greater than or equal to 0. So again, formal, f of x such that f of x is greater than or equal to 0. Okay, so there's example 1, there's finding domain and range. Alright, so another piece of information up here is transformations of square root functions. This is also true for any graph that you may have. We're going to have a horizontal translation and a vertical translation. So, for example here, if you are adjusting inside the radical, that's going to give you a horizontal translation. Okay, so if h is positive, which means, so this is where it's kind of, I don't know, a little backwards may not be the right way to put it, but that's kind of how I put it for my students, is that because the formula says x minus h, that tells me that if h is positive, I'm going to move to the right. I know that typically when it looks, because it'll look like this, so let's say like x minus 3. Technically h is positive there, but to me, looking at x minus 3, I would think to move to the left, but because h is positive, we are moving to the right. That is a positive shift, and the positive numbers are on the right. I'm trying to explain that the best way that I can. If h is negative, So let's say we have a negative 3, we would have this, we would have x minus negative 3, and that's where you get that minus a negative, so x plus 3. So that's actually going to be a shift to the left. So anything inside the radical connected to the x, either added or subtracted from the x inside the radical, is going to be a horizontal shift, either right or left. A vertical shift happens when you've got a value being added to the outside. So outside of the radical, we have a positive k or a negative k, and whichever one it is determines if it's going to go up or down. So a positive k is going to shift the whole parent graph up, and a negative k is going to shift it down. So if we're adding 5, it's going to move up 5. If we're subtracting 5, it's going to go down 5. The a value, so the number out front right here, this value is going to change quite a bit. It depends on if it's positive or negative, greater than 1 or less than 1. Okay? The a value itself, if it's a negative, so let's say it's negative 2, it's going to reflect the entire graph over the x-axis, so it's going to flip it kind of upside down. If the absolute value is greater than 1, so negative 2, the absolute value of negative 2 is greater than 1, so it's going to stretch it vertically, which means it's going to be a lot steeper. Which, kind of makes sense, because if you're multiplying by something, it's going to go higher faster. Whereas the parent graph might look something like, so here's the parent graph. It's a little more narrow. Whereas if we multiplied by a number, it would be vertically stretched. I am messing up my words. If a is a fraction or a decimal, it's in between 0 and 1, so let's say it's 1/2, that's going to be compressed vertically, which means it's going to be a lot more narrow, so it's going to go like that. It's going to be a little more flat. So whatever a is, a has a lot of different things that is going on with it. If it's positive, it's going to be above the x-axis. Negative, it's going to reflect across the x-axis. If the absolute value is greater than 1, it's going to be stretched, it's going to be more steep. And if the absolute value of a is in between 0 and 1, it's going to be a little more flat, a little more narrow. So we're going to use that to hopefully help us graph this. We could still make a table, which I think I'm going to end up doing anyway, just to check my points, make sure we're in the right spot. But let's look at this one here. It says graph each function, state the domain and range. So we've got example A, and I'm going to show you part B as well. So what I'm going to do is I'm going to find my starting x value. So whatever makes this in here equal to 0. So my starting x value, I think, is going to be 2. And then I'm going to just plug in some points, 3, 4. This part doesn't quite matter. I'm just making the table. Then I'm going to plug each one of those in. So if I plug in 2, 2 minus 2 is 0, square root of 0 is 0, plus 5, so 2, 5 is going to be my first point. If I plug in a 3, 3 minus 2 is 1, square root of 1 is 1, plus 5 is going to be 6. And I can keep going for that. If I plug in a 4, I'm going to get about 6.4. If I plug in a 5, I'll get 7. 6 is going to be 7.2. 7 is also going to be 7.2. So you can see it's kind of getting a little more narrow as you go up. So I'm going to plug these in. I'm going to graph this. So 2, 5 over 2 up 1, 2, 3, 4, 5. So here's the beginning of my graph. Okay, so from here I already know my domain has to be everything greater. Everything greater than or equal to 2. Because anything less than that would give me negative square roots, and I don't want those. Next part is 3, 6. 4, 6.4, so it's kind of like right there. 5, 7. 6, 7.2, and as you can see, it's just going to start crawling up. It's going to get a little more flat. So we're going to pay guess, but not that bad. So we've graphed it now. You could take your normal function, and I'll do that probably on the next one. You could take your parent function. We know that it starts here, and it kind of use a different color. It goes like this, 4, 2, and then 5, 6, 7, 8, 9. So here's our parent function. So as you guys can see, we have a right shift of 2, 1, 2, and we went up 5, 1, 2, 3, 4, 5, and that's where our graph is now. So you can jump to doing it that way instead, or you can make a table. So our domain we already talked about, all of the x values that are greater than 2, and then our range, well, where do our y values start? Y values start right here with our x values. It starts up here at 5, so the y values, f of x, output, has to be greater than or equal to 5. So this next one is y equals -2 times the square root of x plus 3 and then minus 1. So you could do the parent function, you could move it. This one would have a reflection over the x-axis because it's a -2. It would also be stretched vertically, which means it would be more steep. We are adding 3 to it, which means we're going to shift to the left 3, and then we are subtracting 1, so we're going to go down 1. There's a lot going on with this one, so I think I'm just going to go with the table. So my initial x value is going to be -3, because that's what's going to make under here 0. So my domain has to be everything, all the x values that are greater than or equal to -3. So I'm going to start with -3, -2, -1, 0, 1, 2, 3. So I'm going to go through and I'm going to plug each one of those in. If I plugged in a -3 and did all of my math, I would get -1. If I plug in a -2, I'll get -3. I'm just going to, I am cheating, I have the book, but I'm just plugging all of these x values in. If I have a 0, -4.5, -5, -5.5, and -5 9/10. Okay, so there are my points. I'm going to come over here and graph them. So -3, 1, 2, 3, -1, -2, -3, 1, 2, 3, -1, -3.8. So kind of down here, closer to 4. 0, -4.5. 1, -5. Okay, let's see how this goes. So my first initial point right here. Ooh, I missed a couple points, but that's all right. That's what my graph will look like. My domain, again, x is greater than or equal to -3, which means my range, and I could leave it as y. The last one I could have left as y because it started as y. The highest y value here is -1, and they go lower and lower and lower from there. So it's actually, this time it's going to be everything less than or equal to -1. Alright, so in this last example, which if you guys are following along in the book, it is actually example 4 because I skipped example 3, but for the sake of our notes, and I didn't even label it here, so I guess it doesn't matter to you, but this is example 3. So a square root inequality is an inequality involving square roots. Who would have thunk it? They are graphed using the same method as other inequalities. So we have talked about this before. I don't know if you guys remember, like we haven't. I haven't been with you guys for this, but graphing linear equations or quadratic equations where you have, the dotted line, the solid line, shaded in or outside of the parabola or above or below the line. This is what we're talking about here. So we're going to first graph this, and then we'll pick it apart when we graph it. So again, first x value I'm going to start with is going to be 4. And so if I make just a quick XY table, if I plug in 4, 5, 6, 7, 8, and so on, okay, 4 minus 4 is 0, square root of 0, this is going to be negative 6. If I plug in a 5, I'll have 5 minus 4, which is the square root of 1. 1 minus 6 is going to be negative 5. If I plug in a 6, 6 minus 4 is 2. Square root of 2 minus 6 is going to be about negative, we'll say 4.6. If I plug in a, sorry, hold on. If I plug in a 7, I'm going to have the square root of, well, 7 minus 4 is the square root of 3, minus 6 is about negative 4 point, we'll say 3. And then 8 minus 4 is 4, square root of 4 is 2, minus 6 is going to be negative 4. So as you guys can see, it's going to start coming up a little bit. So I'm going to put my points on here. I am going to start with this point of 4, negative 6. Now here's the thing. We don't have an equal sign here. And I shouldn't underline it because that does mean something different. We don't have an equal sign here. Okay, so it's not including these points that I just put. So what I'm going to do is I'm going to leave an open circle at the point 4, negative 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So there is an open circle right there. And then I'm going to go through and keep plugging in the rest of these. So 5, 5, negative 5, 6, negative 4.6, 7, 4.3, 8 is 4. So since it doesn't include any of these, if you recall what to do, we're going to draw a dotted line. So dot, dot, dot. And it's going to go up and out like that. Okay, so from here, I know that all of my y values are going to be less than this piece. So some of us might be able to just kind of like jump to, okay, I'm just going to shade this below. However, we should be testing points. So let's shade it and then see if we're correct. Okay. Now remember, we can't shade anything to the left of this x equals 4 line because that would give us imaginary solutions, and that's not what we want. So I'm going to pick a point. I'm going to pick the point 13, 0, and I'm going to see if that's true. So I'm going to plug in 0 for y. I'm going to plug in 13 for x. I'm going to see if I get a true statement. If I do, then that's where the shading should be. So 13, 0 is going to be up here on the line. So that's not where we shaded. So we want this to be a false statement because we've already shaded. So I'm going to say 13 minus 4 is the square root of 9. Square root of 9 is 3 minus 6. It's going to be negative 3. Is 0 less than negative 3? That's not true. And we didn't shade up there, so we're fine. So that's how you graph square root inequalities. I recommend picking a couple test points above and below your line before you shade, not like I just did. That way you know that you shaded in the right region or that you're about to shade in the right region. So good luck. Keep up the good work. You're rock stars.